In this chapter, we're going to learn about the periodic table, but at this point in your chemistry journey, you should have been introduced to certain features of the periodic table already. So let's start by doing a recap of some of these features. So this is the all familiar periodic table. As you can see, it contains all the elements that we have discovered up till now, and these elements are arranged in order of their proton numbers, or the number of protons. So we start with hydrogen as element number 1, followed by helium with proton number 2, and lithium with proton number 3, and so on. So the elements in the periodic table are arranged in order of ascending proton numbers. Now furthermore, these elements are grouped into vertical columns and horizontal rows. There are 8 vertical columns, and then the vertical columns are called your group. So we have group 1 all the way to group 0. Okay, one thing to take note is that when writing the group number, we always use the Roman numeral in the O-level context. Each horizontal row we call them a period, and for period we write them with the usual numbers that we have been writing: period 1, period 2, period 3, and so on. Now furthermore, we have learned in atomic structure that the group and period number actually signifies something about the element. So let's do a quick recap again. Now in the chapter of atomic structure, we have learned firstly how to obtain the number of electrons of each element, and then how to arrange the electrons in an atom in a form of electronic structure. So what we have here is the first 20 elements with the electronic structure shown in the periodic table form. Now with this diagram, it becomes very obvious that elements in the same group, they share certain features. Element in the same period, they share certain features. So let's focus on the elements in the same group. We have lithium, sodium, and potassium. They are found in group 1. Now why are they found in group 1, or what features do they share, is that if you can spot, all 3 elements have 1 electron in their outermost shell, or they have 1 valence electrons. And then similarly for elements in group 2, they all have 2 valence electrons. So what does that mean? It means that your group number can actually tell us the number of valence electrons. Another way of looking at it would be elements in the same group would have the same number of valence electrons. Now across the period, if we look at across period 2, what do we notice? Or what feature do all the elements in period 2 share? The feature would be that they have the same number of electron shells. Okay, so essentially the period number tells us the number of electron shells, or number of electron shells that are occupied. Another way of looking at it would be the elements in the same period have the same number of electron shells that are occupied. Now one last thing that we learn about the periodic table is this, that as we move across the periodic table from left to right of the periodic table, the elements change from metals to non-metals. Okay, in the context of O levels, a very convenient way of remembering is this: group 1, 2, 3, elements that are found in group 1, 2, 3 are usually metals. Elements found in 4, 5, 6, 7, and 0 are non-metals. Okay, so as we move across the period from left to right, the elements become less metal-like and more non-metal-like. So how do we describe that? We say that the metallic character decreases. So these are the 4 points that we have just recapped. One is that elements are arranged in order of ascending proton numbers. Next, the group number tells us the number of valence electrons, or elements in the same group have the same number of valence electrons. And the period number tells us the number of electron shells, or that the elements in the same period have the same number of electron shells. And lastly, as we move across the period from left to right, the elements change from metals to non-metals, meaning the metallic character of the elements decreases. Now at this point you may be wondering, so what exactly is metallic character? Now in chemical bonding we have learned that metals, they tend to lose electrons in order to achieve a noble gas electronic configuration, whereas non-metals tend to gain electrons to achieve a noble gas configuration. Now, so when the metallic character decreases, it simply means that the elements have a lower and lower tendency to lose electrons. They become less likely to lose electrons. So before we go on and study more about the periodic table, it's worthwhile to think why is it useful for us to group elements into groups and periods? Or in life, why is it useful for us to categorize people, for example Asians, Americans, Europeans? How does that help? In a way, by grouping people of similar background or that shares similar features, we can use it to predict certain characteristics or certain behavior. This is the same for elements. So when we arrange elements into different groups, what are we looking out for? Would be that we are looking out for the common behavior or characteristics of the elements in the same group. They tend to share certain similar characteristics. Now there is an underlying chemistry reason for that. It's because when elements undergo reaction, it's usually the valence electrons that's involved in the reaction. So when elements in the same group share the same number of valence electrons, they tend to undergo similar reactions. The other thing that we want to look out for when we arrange elements in a group is that when we go down a group, there will be a gradual change in certain properties, as we'll see later. So bear in mind that when we look at the different groups of elements later on, bear in mind that we are focusing on a few things. We are focusing on, for each group, what are the common physical and chemical properties, as well as the trends. How do these properties change when we go down the group? So in the context of O-levels, we're going to look at 3 groups of elements: group 1, group 7 and group 0. And then we're going to look at this block of elements between group 2 and group 3 as well. These block of elements are not assigned a group number, so we call them transition elements.